Grade 12s, we're on our 7th day of exponential logarithmic functions, and today we finally look at logarithms. So if we have a function, y equals c a to the x, which we've been looking at the last while, and we know the value of the exponent, we know we can solve for y very easily just by substituting x into that equation. It's been a little more tricky finding x if we know y. We've been looking at graphing, observation, trial and error. But none of those methods are easy or accurate for all cases. So there must be a better algebraic method, and there is. Logarithms were developed to solve exponential equations. They are the opposite of a power. So if we know that 10 to the a equals b, then log 10b equals a. So they are the opposites. This 10 is the base. In a power, the 10 is considered the base in the log. For example, if 10 to the 1 equals 10, then the opposite of that, log base 10 of 10, is 1. If 10 squared is 100, log base 10 of 100 is 2. Log base 10 of 1,000 is 3. Probably having those examples at your fingertips is the easiest way to understand log. There are other bases. There's an infinite number of bases for logs as well. So since 5 squared equals 25, then log base, kind of our former answer, equals former exponent. So log base 5 of 25 is 2. Conversely, log base 2 of 64 equals 6 because 2 to the 6 equals 64. Our calculators have base 10. We know that the answer to the first one, which is log base 10 of 100, is going to be 2 because 10 squared equals 100. If you type into your calculator and the log button doesn't say log base 10, it's just log. So if you do log 100 in your calculator, mine is a second function button, log of 100, and you will get the answer 2. This one is trickier to think of as a power because 10 to the what equals 52. It's not quite so simple, but we can get an answer on our calculator. Log of 52 is 1.72. Does it make sense that 10 to the 1.72 is 52? Yes, because 10 squared is 100, 10 to the 1 is 10, and it's in between the two. Log base 10 of 360 is 2.56. That makes sense because 10 squared is 100, 10 cubed is 1,000, and 360 is between the two. Okay. I wrote this next little bit down on your sheet because I would never expect you to regurgitate this, but log base 2 of 8 is 3 because 2 cubed is 8. So on the second line, I replace that 8 with 2 cubed. So it's still the same expression. Log base 2 of 2 cubed is 3. My third line is true because log base 2 of 2 is equal to 1 because 2 to the 1 is 2. I wanted to show you that for log base 2 of 2 cubed, it would be the same as bringing down that 3 and writing it as 3 log base 2 of 2. Okay, we're going to try this one. Log base 3 of 81. 3 to the what is 81 is basically the question that I'm asking myself, and this number would be nice. 3 to the power of 4 is 81, so that's a nice one. But what about log base 3 of 5? That's not going to be such a pretty number. Here's how we would solve it. I'm going to take the log of both sides. Sorry, I'm going to write it in a different form, and then I'm going to take the log of both sides. Our calculators don't have log base 3. That's the problem with this. So we want to convert it so that we can. If log base 3 of 5 equals x, then I can rewrite that as equally true statement 3 to the x equals 5, which I also can't solve. But I can take the log of both sides. So I'm going to rewrite, take log base 10, because that's what my calculator has, of both sides. Log base 10 of 3 to the x equals log base 10 of 5. From the example here, which was complicated at best, if I have a log, I can bring down that exponent x. I can rewrite it as x times log base 10 of 3. And we're going to spend more time with these the next couple of days. That allows me to get x by itself by dividing both sides by log base 10 of 3. I'm not going to write that 10 anymore because your calculator won't have it. It's just assumed to be log base 10. So I can get my x value on my calculator by log 5 divided by log 3, which is approximately 1.465. Does it make sense that 3 to the power of 1.465 is equal to 5? Yes, it should. Let's do a couple more. Log base 2 of 15 equals x. My problem is I haven't got log base 2 on my calculator. So I'm going to rewrite that as, if I write it exponentially, that means 2 to the x equals 15. What is my value of x? So I'm going to take the log of both sides. Log with no base is assumed to be 10. I can rewrite that as x times log of 2 log 15. To get x, I'm going to do log of 15 divided by log of 2. And my answer is 3.91. The reason why we do this, we will get into a little later, but this is the method we would use to solve. Example number 3. 5 to the 1 minus x equals 36. I'm going to take the log of both sides. For the second line, I can take that exponent down. Again, the y we'll get into later. Log base 10 of 5 equals log base 10 of 36. So I will get an answer for 1 minus x when I do log 36 divided by log of 5. One minus x is approximately equal to, we need a calculator, 2.22657. I am going to subtract 1 from both sides. And lastly, divide by negative 1. X equals negative 1.22657. So I was able to solve an exponential equation in a new way by using logs. Express 8 as a power of 5. So 8 to the what? Sorry, 8 equals 5 to the what? And I want to find that value of x. So again, I'm going to take the log of both sides. Log of 8 equals log of 5 to the x. With logs, I can bring down that exponent. Divide both sides by log 5. Log 8 over log 5 is the value of that exponent x. And using a calculator, I come up with approximately 1.29. Does it make sense that 5 to the power of 1.29 would be a little bit bigger than itself, 8? Yes, absolutely. So we need to try enough of these from the handout that I'm going to give you, 73 and 75, to be comfortable with logs.